Welcome, everyone. Today we're diving into the Woods Nickel Strike Bath, a key process for achieving high adhesion nickel plating on challenging substrates like steel and stainless steel. We'll explore makeup chemicals, process sequences, and best practices to ensure top quality results. This guide is designed for electroplating professionals aiming to optimize their plating operations across brass, copper, steel, and industrial applications. Let's get started with a comprehensive technical overview that will enhance your plating expertise. Let's take a quick look at what we'll cover. We'll start by understanding what Woods Nickel Strike is and why it's so important. Then, we'll break down the bath composition and the chemicals you need. After that, we'll discuss the operating parameters to keep your process consistent. We'll walk through the process sequences for different metals, cover maintenance and troubleshooting, and finish with safety and best practices. This roadmap will keep us focused and ensure you get the full picture. So, what exactly is Woods Nickel Strike? It's an acid nickel chloride strike bath developed by Donald Woods, known for its extremely low pH and high chloride content. This bath deposits a thin flash layer of nickel that activates difficult substrates, especially stainless steel, by breaking down passive oxide layers. Operating at room temperature with high current density, it creates a strong metallurgical bond. The benefits include superior adhesion, fast activation, and compatibility with various topcoats. It's essential for stainless steel and recommended for oxidized steel, while milder methods suit brass and copper better. Now, let's talk about the standard bath composition. The core ingredients are nickel chloride hexahydrate at 240 grams per liter, providing the nickel ions, and hydrochloric acid at 125 milliliters per liter, which keeps the pH extremely low to activate surfaces and prevent passivation. High purity chemicals are crucial here to avoid contamination. Some variations exist, with nickel chloride ranging from 180 to 300 grams per liter and acid levels adjusted accordingly, but always verify with your supplier. Maintaining the right balance ensures consistent activation and bath longevity. Moving on to the chemicals and materials required, high-purity nickel chloride hexahydrate is your primary nickel source, with low heavy metal impurities preferred. Hydrochloric acid must be handled carefully due to its corrosive nature. Deionized water is critical for purity, and using electrolytic or S-depolarized nickel anodes in titanium baskets with polypropylene bags helps prevent contamination. For operation, you'll need pH monitoring tools, nickel analysis methods, a rectifier capable of delivering the right voltage and current, proper ventilation to handle HCl fumes, and personal protective equipment to keep operators safe. Operating parameters are key to consistent results. Woods Nickel Strike works best at room temperature, around 20 to 32 degrees Celsius, since higher temperatures can shorten bath life. The pH must stay below 1, maintained by hydrochloric acid additions, because this acidity is essential for activation. Current density ranges from 25 to 75 amperes per square foot, ensuring vigorous hydrogen evolution that activates the surface. Voltage varies, but typically sits between 3 and 6 volts. Plating time is short, usually 1 to 5 minutes, with 2 minutes typical. Agitation is mild or optional, as too much can reduce throwing power. Here's a typical workflow for Woods Nickel Strike applications. It starts with an alkaline clean to remove oils and dirt, followed by thorough rinsing to prevent contamination. Then comes acid activation, tailored to the metal type, another rinse, and the Woods Nickel Strike itself, usually 2 minutes at room temperature with high current density. After an immediate rinse to remove acid dragout, the main plating layer is applied, whether bright nickel, copper, or gold. Finally, A hot rinse and drying step prepares the part for inspection, ensuring adhesion and coverage meet quality standards. When working with steel and stainless steel, Wood's Nickel Strike is highly recommended or even essential. For carbon or mild steel, the process includes anodic alkaline electrocleaning, thorough rinsing, acid pickling with hydrochloric or sulfuric acid, and then the wood strike at moderate current density. For stainless steel, the activation is more aggressive, using stronger acid or anodic etching, followed by a wood strike that often starts anodic before switching cathodic. Immediate rinsing after strike is critical. Then, bright nickel plating and adhesion testing complete the sequence. This ensures the passive layers are properly broken down for strong bonding. For brass, copper, and other metals, Wood's Nickel Strike is usually not recommended because it's too aggressive. Instead, a milder activation with a dilute sulfuric acid dip or proprietary activator is preferred before moving directly to bright nickel or copper strike. Aluminum requires a zincate process first, followed by copper strike, and then nickel plating. Woods can be used after copper strike if needed. Zinc die-cast parts need zinc stripping and copper strike before nickel, with woods used for extra adhesion if necessary. Nickel alloys behave like stainless steel and respond well to wood strike after proper cleaning. Always test adhesion on new substrates to confirm process suitability. Maintaining and controlling the bath is vital. Regular analysis of nickel concentration, targeting around 59 grams per liter of nickel metal, helps keep the bath balanced. Acid concentration must be monitored and maintained through titration or pH trends, as drag-out and neutralization reduce acidity over time. Contaminants like iron, copper, zinc, and lead can harm the deposit, so dummy plating at low current density and carbon treatments help purify the bath. Equipment care includes inspecting anode bags and baskets, checking electrical connections, and ensuring good ventilation and tank integrity to protect both the process and personnel. Troubleshooting common issues starts with poor adhesion or peeling, often caused by insufficient activation, poor cleaning, or low current density. Remedies include increasing acid strength or pickle time and verifying rinse quality. No deposit or poor coverage can result from low nickel or acid levels, poor contact, or anode problems. Adjusting chemistry and checking connections helps. Rough deposits often stem from particulates or high current density, so filtration and carbon treatment are key. Pitting relates to organic contamination or low acid, fixed by carbon treatment and agitation. Burning at edges is usually from excessive current density, and contamination from impurities requires better rinsing and high purity chemicals. Safety is paramount. Operators must wear acid-resistant gloves, goggles or face shields, chemical-resistant aprons, and rubber boots. Respirators may be needed if hydrochloric acid fumes are significant. Ventilation systems, including local exhaust and scrubbers, help control fumes, and air quality monitoring is essential. Always add acid to water slowly, never the reverse. Store chemicals separately with secondary containment and clear labeling. Spill kits should be readily available. Waste must be neutralized before discharge, with nickel precipitated or recovered, and all disposal must comply with environmental regulations to protect people and the environment. To sum up, Wood's Nickel Strike is your go-to for steel and stainless steel adhesion, using a standard makeup of nickel chloride and hydrochloric acid with high purity. Operate at room temperature, low pH, and high current density for short times, always followed by thorough rinsing. For brass, copper, and aluminum, milder activations are better. Maintain your bath with regular analysis, dummy plating, and filtration. Safety can't be overstated. Use proper PPE, ventilation, and waste handling. Test adhesion regularly and train your team on sequences and rinsing. Partner with trusted suppliers for consistent quality and support. That brings us to the end of this technical guide on Woods Nickel Strike Bath. I'm Selvaraj Venkatesan from Excel Laboratories and SS Trading in Coimbatore. Feel free to reach out via mobile or email for any questions or further support. This resource is designed to empower your electroplating operations with reliable, high-adhesion nickel strike processes. Thank you for your attention, and I look forward to your success with Woods Nickel Strike.